Hello everyone, this is Mr.DHAKSHUNHAAMOORTHY, Assistant Professor, Department of Artificial Intelligence and Machine Learning. Subject code 21CS003, Mobile Application Development. Subject handle to the class 3rd year, 5th semester. Today's topic is mobile memory management and design patterns for limited memory. Where two applications have the same priority, the process that has been at a lower priority longest will be killed first. The process priority is also affected by inter-process dependencies. If an application has the dependency on a service or the content provider supplied by second application, the second application will have at least as high a priority as the application it supports. All Android applications will remain running and in memory until the system needs its resource for other applications. The chain of activities, active process, visible process, started service process, background process and empty process are categorized based on the priority. So active process comes under critical priority, visible process, started service process comes under high priority, background process and empty process comes under low priority. Active process, foreground process are those hosting applications with the components currently interacting with the user. These are the process Android is trying to keep responsive by reclaiming resources. There are generally very few of these processes and they will be killed only as a last resort. Activities in an active state, that is, they are in the foreground and responding to the user events. You will explore activity states in greater detail later in the chapter. Activities, services or broadcast receivers that are currently executing an on-receive event handler. Services that are executing on-start, on-create or on-destroy event handler. Now the second priority level, that means high priority level, in which a visible but inactive processes are those hosting visible activities. As the name suggests, the visible activities are visible but they are not in the foreground or responding to the user events. Started services is also comes under high priority. The processing host services that have been started, service support ongoing processing that should continue without visible interface. Because the service don't interact directly with the user, they receive a slightly low priority than the visible activities. They are still considered to be foreground process and won't be killed unless the resources are need for active or visible process. Background processes, the processing hosting activities that are not visible and that don't have any services that have been started the considered background processes. They will generally be large number of background processes that Android will kill using last seen first killed pattern to obtain resources for foreground process. Empty processes, to improve overall system performance, Android often retains applications in memory after they have reached the end of their lifetimes. Android maintains the cache to improve the startup time of applications when they are relaunched. These processes are routinely killed as required. DDMS, Android Studio include a debugging tool called Dalvik Debug Monitor Service. DDMS provides service like screen capture on the device, threading, heap information on the device, log cat, processes, incoming calls, SMS checking, location, data spoofing, and many other things related to testing your Android applications. DDMS connects the IDE to the applications running on the device. On Android, every application runs in its own process, each of which hosts its own virtual memory, and each process listens for a debugger on the different port. When it starts, DDMS connects to ADB, that means Android Debug Bridge, which is a command line utility included with the Google Android SDK. And Android debugger is used for debugging the Android app and starts the device monitoring service between the two. This will notify DDMS when a device is connected or disconnected. When the device is connected, a VM monitoring service is created between ADB and DDMS, which will notify DDMS when a VM on device is started or terminated. Second topic, design patterns for limited memory. When composing designs for devices with a limited amount of memory, the most of the principles is not to waste the memory. As pointed out by Noble and Weir 2001, this means that the design should be based on the most adequate data structures which offers the right operations. The first data structure is linear data structure. In contrast to the data structure where a separate memory is reserved for each of them, linear structures are those where different elements are located next to each other in the memory. Examples of nonlinear data structures include common implementation of list and tree-like data structures, whereas linear data structures can be lists and tables, for instance. Difference in allocation in memory also plays a part in the quality properties of data structures. Linear data structures are generally better for memory management than the non-linear ones for several reasons listed in the following. List fragmentation. Linear data structure occupy memory place from one location, whereas non-linear data structures once can be located in different places. Obviously, the former results in less possibility for fragmentation. Less searching overhead. Reserving a linear block of memory for several items only takes one search for suitable memory element in the runtime environment, whereas nonlinear structures require one request for memory per allocated element. Combined with the design where one object allocates a number of child objects, this may also lead a serious performance problem. Design time management. Linear blocks are easier to manage at design time. If fewer reservations are made, this usually leads to cleaner designs. Thank you.